Welcome to Math with Mrs. Cox. We are on Chapter 6, Lesson 9, Homework, Estimate Quotients, page number 433. Now, what you need to understand with this homework is you do not have to have precise estimation. You're looking for compatible numbers. This example is great. 78.74 divided by 42. Those are not very fun numbers. And they round both of them and put 42 to the nearest 10. Then 78 can be closer to 80 because 80 and 40 are definitely compatible, and we can do that in our head as 2. So 78.74 divided by 42 is about 2. Okay, you may want to grab some graph paper for this or just write really neatly. You decide. Make sure it's neat enough that Mrs. Bean can correct it. Number 1, 32.17 divided by 7. Well, I'm going to change both of those numbers because I know that 8 gets along really well with 32. So 32 divided by 8 would be 4. Number 2, 175 divided by 32. Well, I'm going to keep the 3 because I know that 3 gets along well with 18, and 180 is pretty close to 175. So then I know that that should be about 60, and there's a dollar sign there, so I got to put dollar signs right there. Number 3, I'm going to keep the 3, then the divisor, and do 21 is a little more compatible, and my answer is going to be 7. Okay, 36.3 divided by 6. Yep, you've got it. All right, 17.5 divided by 5. Well, I'm going to keep the 5, but I'm going to bump the 17.5 up to 20 because that's a little more compatible. And that works a lot nicer. Number 6. Well, I'm just going to round it to 120 because then I know that 12 divided by 2 equals 6. Bring the 0 over is 60. Okay, check your work. All right, the information in the table can be used to determine the density of the object. Density describes how tightly the particles in an object are packed together. You can find its density by dividing an object's mass by its volume. Okay, so they're just trying to confuse you here with some crazy stuff. This is stuff we can do. We need to find the density of aluminum. Aluminum. That's one of those words you could say like 5 times and it still comes out funny. So here is aluminum, and we are doing the density of aluminum divided by the volume. So we just need to divide those two numbers. Now, they do not get along very well. So let's bump up the mass to 15 because that will be a little more compatible with 5. And that's all they're trying to teach us how to do is to find compatible numbers. And we know that 15 divided by 5 is 3. And then we need to see this little measurement right here is what we have to add on the side. So we're going to say 3 grams/centimeters cubed. I know, because they have to have the grams and the centimeters. That's a dash. Okay, number 8. Is the density of gold greater than the density of merc? So let's compare. I bet this would be a little more compatible for gold if we did 60 divided by 3. That's a little more compatible than 56.7. So 60 divided by 3 would be 20. Okay, we know that to figure this problem out, we do 9 times 12 equals 108. We can do that in our head. That's one of our multiplication facts. So if we alter this number to 108 divided by 9, we know that we have 12 here, and then we have 20 here. Then we can say the density of gold is greater than mercury because gold's density is 20 and that's greater than mercury's density, which is about 12. Now, these are not precise, but we can see through these calculations mentally in our head without doing a lot of crazy calculations that that is the answer they're looking for. So yes. Number 9, the density of gold is about how many times greater than the density of aluminum? It's about 7 times. And this is how you figure it out. They have 21 divided by 3 equals 7. Harry's mother makes cakes for a local restaurant. She buys flour and sugar in large amounts. She has 157.86 pounds of flour and 82.69 pounds of sugar. Okay, they just want to throw out some crazy numbers for you. Here's what we need to do. If she uses 15 pounds of flour and 8 pounds of sugar each day, how many days will they both last? So we're looking, that's a division problem, and that's a division problem. So let's simplify it to compatible numbers. 157 doesn't get along very well with 15, but 150 does. So this is my flour, 150 pounds of flour, and she's going to use 15 pounds a day. So let's see how many days there will be. About 10. Here's the sugar. 82 isn't very compatible, but 80 works a little better with 8 because she's going to be using 8 pounds of sugar a day. So she should have enough sugar for about 10 days. So about how many days would they both last? 10 days. And then point to these equations over here showing that you proved your equations. Number 7, write a division problem involving the division of a decimal by a whole number with the estimated quotient, which means answer, of 7. Compare the estimate to the actual quotient. Ooh, this sounds fun. Okay, let's do something crazy. I know that 42 gets along well with 7, so let's make it kind of a crazy decimal. And let's divide it by maybe, 6. Because then I know that the answer is about 7, right? And 42.6 divided by 6 equals 7.1. And so the estimate right here is 0.1 less than the actual quotient. Or in division terms, we can say quotient. Number 12, Kendall measured the rainfall in her area for a year. Her readings totaled 34.56 inches. What is the best estimate of the average rainfall per a year? Okay, so a year has how many months? They need to know how many per month. I read that wrong. What is the best estimate of I'm tired. I should go to bed. Kendall measured the rainfall in her area for a year. Her readings were totaled at 34.56 inches. What is the best estimate of the average rainfall per month? Okay, there are 12 months in a year. So they want you to give me an estimate. Well, trying to find a number that works really well with 12. I'm going to bump it up to 36 because in my head I can do 36 divided by 12 easily to get about 3. And that right there is close to about 3 inches per month. All right, friends, double check your work. That was a tough one.